All right, everyone, and welcome to the final big one, compressing and stretching, featuring October. We'll see how long she stays there. Oh, nope, she already heard me speak. So she doesn't like stretching and compressing either. She's probably going to move. So this is the big one. This is the big video. This is the end. This is the hard one. And she's going to keep me company while I teach you guys a little bit about that. So let's start by doing a little exploration, like we've been doing before. So if I have the square root of x, we've added, we've subtracted, we've put negatives in. Let's multiply and divide right now. So just kind of looking at this, kind of think, what happens if I multiply the outside by 2? If I multiply the outside by 2, outside should be a vertical change. Multiply is like doubling. So what I say is that if I multiply a 2 on the outside, it should double all the y values. Look at the y values here. They should all be doubling. Sorry, excuse me. And that's exactly what we have. If we divided by 2 or multiplied by 1/2, right? That should multiply the y values by 1/2, and so on. Okay, and that's going to be vertical stretching and compressing, and that's where we're going to start today. Where if we go back to our table, wherever that is, and say vertical stretch and compress. So it's going to be stretching. If we multiply, this is a little weird to write. If we multiply on the outside of the function, it's a vertical change. Vertical change means outside of the function. But specifically, it's a stretch if this factor is bigger than 1. So like 2 or 3. But if it's 0.5, it's not a stretch then, it's a compression. And similarly, this is the same formula, a times f of x, if a is between 0 and 1. So we want a to be positive here. If a isn't positive, then we have a reflection and a stretching, for example. So let's continue looking at some examples. So if we had like 2 square root of x, that would be vertical stretching. And if we had something like 1/2 square root of x, that'd be vertical compression. All right, and the last one is the weirdest one. Okay, so if I multiply by 2 on the inside, you might think that's a horizontal stretch. But let's use a different function. It's a little easier to see. Let's use... I don't actually know which one I want to use. Let's use x squared, I guess. If I multiply by a 2, it does not horizontally stretch it at all, right? If I multiply by a 2, it horizontally compresses, right? It's squishing it together. So it's kind of like how I said earlier that things on the inside of the functions, horizontal things, kind of work backwards from what you might think. So multiplying by 2 horizontally compresses. Just like over here, you might think that adding to the inside will move it to the right, but it's actually the left. So things on the inside are oftentimes a little backwards from what you might think. So horizontal stretch and horizontal compress. A stretch on the end is going to be f times ax, and this time it's stretching for small a's, and it's compressing for bigger a's. Okay, so watch out for these ones. So maybe it's like 1/2 x squared. I'm just going to go away. All right, and now we have our full table of all 10 transformations. vertical shift, up, down, horizontal shift, left, right, reflections, one way, reflections another way, vertical stretching, vertical compressing, horizontal stretching, horizontal compressing. And now we're going to put it all together. Okay. So you have to be really careful. And I'm saying that a lot in these videos. You have to be really careful on which order you do them in. And so I'll give you a good rule of thumb. If there's a lot of different transformations being applied, you have to be very careful, but a good rule of thumb doesn't work in every case, but it works in most cases that we're going to see for this class. For the order, because the order on which you apply these matters. So usually, we're going to want to do horizontal shifts first. We're going to do vertical shifts last. And then everything else will be in the middle in any order. And again, this is just kind of a rule of thumb for the problems that we're going to come across. The actual distinctions here are a little bit more complicated. Okay, but we won't worry too much about that just yet. As always, check your answers with Desmos. Okay, check your answers by graphing it on a computer, on your calculator, etc. So let's combine all of this. I don't know what example number we're on. I'm just going to make it up and say example 6. Example 6, first, describe each transformation. Describe each transformation and give the transformations in the right order. Part A is going to be g of x equals some function with a 2 being multiplied on the inside. All right, so 2 being multiplied on the inside. Which case is that? Goodness, that table's really far. All right, multiplied by the inside. It's one of these. And A is 2, so it's this one. That's a horizontal compression by 2 or 1/2, depending on how you want to phrase it. Okay? Horizontal compression. And when I say you can say either 2 or 1/2, that means we're compressing by a factor of 2. It's the same thing as cutting it in half. Okay, so it's up to you on your phrasing for that. I'll accept either. Do part B. Part B is g of x equals 2 times f of 1/3 x. Now there's multiple things happening here, right? There's a 2 on the outside and there's a 1/3 on the inside. So if we just jump back, this is much faster. A 2 on the outside, multiply on the outside, 2 is bigger than 1. 2 on the outside is vertical stretch by 2. Okay? 2 on the outside, vertical stretch by 2. 1/3 on the inside. And again, you might think, oh, 1/3, that's a small number. That's a compression. Everything on the inside works backwards from what you might think. It's a horizontal compression. And again, you could say it's compressing by 1/3 or by 3. They're both okay. All right. But all of horizontal stretching, I even said it right at the first time and I switched it. Horizontal stretching by 3. All right. Stretching it vertically by 2, stretching it horizontally by 3. And that's our answer here. Part C. G of x equals 5 times x plus 3 squared minus 2. So there's 3 things here, right? Multiplying on the outside, that's a vertical stretch. Adding on the inside, that's a horizontal shift to the left. Subtracting 2 on the outside, vertical shift. Let's make sure to do these in order. Horizontal shift first, vertical shift left. Everything else can be in any order. All right. The horizontal shift is first. We're going to go left 3. Vertical is last. It's going to be down 2. And everything else goes in the middle. That's going to be a vertical stretch by 5. These are the 3 things happening here. And in this one, we can actually check our answer, right? If we look at a standard parabola, and then we say, okay, multiply it by 5, x plus 3 squared minus 2, squared. These should be very similar. Should be move left 3, stretched by 5, and then down 2. So should be vertically stretched. Looks vertically stretched. And it's also left 3 and down 2. All right. And that's this example. Let's do one more. Example 7. Find a formula for this example. I'll give you a graph here that starts right here. And then it goes right here. And then right here. I think I'm drawing it correctly. Oh no, it's one of these graphs again. It's like a half parabola. I just can't do it. Can't draw these by hand. We're going to have to look. So first off, we have to find the toolkit. What's the toolkit function here? It's the one I can't draw. It's the square root of x. All right, but no, let's look at the regular square root of x. Square root of x normally looks like this. This is normally what the function looks like. Ha 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 ha. Something like that. So what's being done to these points? They're getting reflected, right? Reflected about the x-axis. Right? Everything that used to be up here in the toolkit is now down here. That's a vertical change. Vertical means it happens on the outside. So this is what that transformation does. But even after we reflect, right? Even if we reflected, these would be the points. So how do we go from the blue points to the white points? What's happening? Well, let's look at these points, right? This is the point 1, -1. This is the point 4, -2. Whereas the white points are 2, -1 and 8, -2. What's the relationship between these points? Blue and white, blue and white. The x coordinates are getting doubled in the whites. We have to have a horizontal stretch by 2. And that's the logic that you can apply for a problem like this. Our answer should be negative square root of x, but a horizontal stretch means multiply on the inside. Don't multiply by 2. That would be a compression. To horizontally stretch by 2, we have to multiply by 1/2. But don't take my word for it. Check your answers here. All right. Let's go over to Desmos and say, okay, what does this look like? The square root of -1/2. Oops, the negative should be on the outside. Are these the same functions? 0, 0, 0, 0. Same shape. Good. It goes through the point 2, -1. Good. Goes through the point 2, -1. It also goes through the point 8, -2, just like so. Great. So this purple graph is the same as my drawn red white graph, which is what we wanted. All right, and that's this video. You should have all the tools you need. Let me know if you have questions.